Greetings and welcome, friends. Mr. Waddy and my algebra buddies are here. We're talking about solving equations. We were just doing some algebra tiles even, and we encountered a situation where variables were on both sides of the equal sign. What? And then here, this is what they tell us. Solving equations with variables on both sides. So, Jimmy, it says to solve an equation with variables on both sides, simplify one or both sides of the equation if necessary. When it says simplify, what do they mean? They done be talking about doing things like distribution, right? That's what they're referring to, or combining like terms, right? Those are steps that are simplifying. I guess you could also reduce fractions or something like that as well if need be. So do that. And then it says use inverse operations to collect the variable terms on one side. So collect the variable terms on one side. I would call that, right, bring, and I'm actually going to say this, the little variable to the big variable. This is Mr. Waddy's helpful tip. Okay? So that's what we are going to do. So for example 1 here, it says solve 10 minus 4x equals negative 9x. And mis amigos, we have our polls open and ready, currently unlocked. So my friends are going to be voting right now about what to do to this equation to solve. What's the next step to solve that equation? Let's see. We'll give them 10 seconds. Oh, is it locked, supposedly? There you go. Try again. All right. 5, 4, 3, 2. Okay, here we go. Well, we can't really combine like terms in their current state since they're on opposite sides of the equal sign. I'm not going to multiply both sides by anything. That would make things complicated. And I wouldn't divide. I think I actually disagree with everybody here, but that's okay. We're learning. This is a learning experience. I think we're going to move a variable to the other side by adding or subtracting. So, in order to do so, I said my recommendation is to move the little guy, the little variable, to the big variable. Which one is littler, -4 or -9? -4 is closer to 0. -9x. To move a -9x, I'm moving the whole thing. I'm not getting rid of the -9 to get x by itself. I'm moving the whole thing. To do so, I'm going to add 9x to both sides. And notice where I write it underneath its bud, its like term over there. So I'm going to have 10 plus 9x and -4x combined to be 5x equals, uh-oh, what happened? -4x plus 9x is 5x. Nope. I was imagining this as 10 plus like a -4x, and then I combined the -4x and 9x to be. Yep, good question. Also, sometimes when students have 0 show up on one side of their equal sign, they actually will completely forget to write the equal sign. They'll just stop writing all of this, and then like they get super confused because then there's no longer two sides of their equation. So be careful. When things cancel out completely on one side, Jake, it becomes 0. All right, let's see what my friends think my next move is going to be. I'm going to go back to the poll. I'm going to clear the results, move the chart, and unlock it. Let's see what they say. What's my next move to get x by itself? Let's ask the studio audience here at Waddy Math. That's right. Many of these lucky fans got these tickets for free, paid for by the tax dollars of the local school districts and the people who live here. This is great. Yeah, our nation believes that your education is worth it, that you folks are worth investing our tax dollars into. So 10 plus 5x equals 0. You guys said subtract a constant from both sides. That's what I'm talking about. So, mis amigos, this 10 is a positive 10. Let's subtract it from both sides. So I get 5x equals negative 10. Let's see, you guys are going to get this last move. All right, vote. What's the next last move? 5x equals negative 10. Trinley's voting right now. All right, 3. Come on. There's something you can figure out real quick. You either know it or you don't. And if you don't, then we'll talk about it. That's fine. All right. Let's see. Add a constant to both sides. That wouldn't be helpful. If they were referring to the negative 10, I could move it back, but that would bring me back to my previous step. Multiply both sides by a constant. There's a way to do it, but that's usually confusing. X is being multiplied by 5, so the inverse operation is to divide both sides by 5. And I end up with x equals negative 2. All right, so I end up getting a solution to the equation like so. Now, there is a way that if I wanted, when I was at 5x equals negative 10, you could multiply both sides by something. What would I have to multiply both sides by? Guys, stop talking and distracting the group. If I multiply both sides by 1/5, it's technically possible, but I think you guys agree that's a weird way to do it. X is equal to 1/5 of negative 10, which is also negative 2. Now, 1/2 wouldn't cancel out with 5. It would be, it'd be 5/2 x. Yeah. So let's do a check, Ben. I'm going to plug negative 2 in everywhere I saw an x in the original problem and just see if it works. 10 minus 4 times negative 2, is that equal to negative 9 times negative 2? So let's use PEMDAS now. 10 plus 8, is that equal to 18? 18 equals 18, friendos. That's right. That's beautiful. Look at that. That's a thing of beauty. Would you look at that? Okay. Here, ooh, looks like I've got some bonus examples here for us. Mr. Waddy's custom math problems right here. Okay, so step 1, bring the variables to the same side. I will say move the little guy to the big guy. Which one's the little guy here? Yeah, 1x is less than 3x. Right, Kaylin? Yeah. So 3x minus 1x. Oh, guys, actually, sometimes, I told this to my class earlier, sometimes people think that 3x minus x is 3, because it's like you're getting rid of the x, right? That is super illegal. Yeah, I know, but I'm telling you again, because it's super illegal. 3x minus 1x is 2x, plus 2 equals negative 4. Let's see, Jimmy, what's my next move here to get x by itself, you think? Subtract both sides by this 2, I'm thinking. 2x equals negative 6. And let's see, Benny boy, what are your thoughts? How can I get rid of multiplying by 2? Yeah, divide not just this side, both sides by 2. I like it. X equals negative 3. All right. Over here. Let's keep cruising. All right. Trinley, which is smaller, negative 5x or 2x? Yeah. I mean, 5 looks bigger, but it's negative, and yeah, I'd rather have $2 than owe someone $5, right? So, so I'm going to move that negative 5x. Folks, how can I move a negative 5x? Yep, so I add 5x to both sides. Notice that these would swipe, those cancel out. Lovely. I get 1 equals 4 plus 7x. All right, Maya, what should I do now to get x I like it. This is a positive 4. By the way, sometimes, Ben, people mistake this plus sign as applying to that 4, which isn't a big deal unless it's a minus sign. All right, so just be careful there. We'll subtract 4 from both sides. So I'm going to get -3, -3 equals 7x. All right, Jake, this is going to look weird in the end, but what's the right thing to do as my next move to get x by itself? By what? I like it. Yeah, x is being multiplied by 7. And even though it's going to be fractions, hey, at least they showed up at the very end of the problem and not halfway through. And then using symmetric property of equality, I can flip it. Oh, what's your question? It sounds like a good one. All right here. Right, if I add 3 to both sides, yeah, my goal, my target is always to get the variable by itself. All right. So this actually isn't helping x get by itself. It ended up bringing more people to its side. So my goal is to get everything away from the variable. And in this case, I couldn't even do that until I got all the variables together. And then I targeted this, and I'm trying to get this by itself, this by itself. And notice it gets lonelier and lonelier as time goes on. That's actually really sad. It's really sad. So this is allowed. It just didn't end up helping us. It made the problem more complicated, not less. All right, so let's take a look at example 2. Oh dear, oh dear, oh dear. All right, guys, we're gonna take this to the vote. Example 2. You guys already have this in your packet. Flip the page if you need to. I'm gonna clear. I'm gonna get rid of the chart. I'm gonna unlock. All right. Vote it. All right, internet friends, let's see what the vote said. I'm sorry, internet friends, that I'm not broadcasting this live and you can't participate in the vote, but you can play the home version of Waddy Math. Feel free to write down your best guess as to what the next move was. Let's see what our local audience suggested. I like what I'm seeing here. Now, technically, whoever said multiply, distribution is a type of multiplication, but, oh, you could, if I, guys, wait. If I multiply both sides by this denominator, I could actually kill the fractions outright. But I'm guessing that's not what they were thinking about. The correct move is distribute fractions. 3 times 3x is 9x. 3 times -4 is -12. What's a quarter of 32? Another way I could phrase that is 32 divided by 4. Yeah, so a quarter of 32x is 8x, and a quarter of 56 is 14. All right, there we go. I've distributed. Let's go back to the polls. Let's clear them. All right, what's my next move? We're thinking. We be thunking. Yeah, there's a lot of things that you're allowed to do, but they're not always helpful, friends. Not always helpful. Yeah. All right, let's see what these the local audience thought. Hey, where's my results? Here we go. Lock it, show it. Ooh. Guys, I wouldn't add a constant to both sides. I mean, I can add 12 to both sides, but I haven't decided what side I'm bringing x to yet. You're allowed to do that. You might even have had the forethought of I'm going to keep the x over here, and so adding that 12, you could do that. Yeah, what's your thought? Yeah. Mm-hmm. Right. So you're preemptively planning on moving this 8x. Okay. I would move the x first. I would not mark you wrong at all for that move. Fully legal, fully correct. All right. It's not my recommended approach, but it's also not wrong. Not wrong at all. So you could do that. Combine like terms. I'm going to say that one is wrong because no like terms are on the same side of the equal sign. So I can't do that. The one I would have said is move a variable to the other side by adding or subtracting. And who should I move? The 9x or the 8x? And how do I move a positive 8x? Yeah, subtract 8x from both sides. Lovely. And so 9x minus 8x is 1x. And then now I would end up moving the 12. But yeah, you could have moved it first. I will not mark you wrong. I get x equals 26. Lovely. All right. Let's have you guys. We're going to have you guys try these 3 problems. You can work with a buddy. And I'm going to say goodbye to our internet friends. But they could try this at home and maybe write their answers in the comments below. Thanks. Bye-bye.